let us see how to solve this problem. This is a cantilever beam of span 12 feet. We have two different UDLs here. It is 2000 lb per feet from 0 to 6 feet, and it is 1000 lb per feet from 6 feet to 12 feet. So you can model this member AC as a single member, and you can give these two loads as partial UDLs. This is from 0 to 6 and this one from 6 to 12 feet, and you can give this 5000 lbs load as a member load, that is concentrated load at a distance of 6 feet. That is one way to solve. Another way is to draw this beam in two pieces, that is, we'll draw AB and we'll draw BC. That means we'll have a node here, and we will give this load as a full UDL on member AB, and we will give this UDL as a full length UDL on member BC, and we will give this load as a nodal load at point B, and then we can find the deflection at B. So now I'll follow the procedure number 2, what I've said, and we'll solve this problem. I'll say File, New, it's plane, it is feet and pounds, because the units here are pounds per feet. Now I'll say Next and say Finish. Now I need to have 12 lines, each 1 feet, because the total length of this beam AC is 12 feet. Now I'll draw 6 feet and again 6 feet, and I'll close this grid. Now this is a beam what we have. You can confirm the dimensions. So this is a 12-foot cantilever. I'll remove the dimensions now, and I'll say General, and I'll go to Property and say Define, and I'll give a property 1.5 foot by 1 feet. Add, Close. Now I'll select these two members. I'll say Assign. Now I need to give the fixed support, and this one at the left side. I'll say Assign, Yes. Now I need to define two UDLs and one nodal load. That's what I'll do here. This is 2000 lbs per feet and this is 1000 lbs per feet, and this is a point load acting on the node. So I'll say Add. I'll go to member load. I'll say minus 2000 lbs per feet. I'll say Add, and I'll again give minus 1000 lb per feet. I'll say Add. That's what you can watch here. Now I'll go to the nodal load and give a point load of minus 5000 lbs. I'll say Enter and say Escape. Now we can pick this 2000 lbs, give it on this member and say Assign, Assign, Yes. And you can pick this one, give it on this beam, and you can say Assign and say Assign. And this particular nodal load, you're supposed to take the node cursor and select the node something like this, and you can say Assign to selected nodes, and you can say Assign. Yes. Now these are the loads that we have. Now we can solve this problem. I'll say Analyze, Add, I'll say Close. I'll run this problem. The problem is solved. I'll say Done. I'll go to Post Processor, and this is the deflection diagram. Of course, this is the bending moment diagram, and this is the shear force diagram. And let me switch on the deflection. The question here is, what is the deflection under point B? For that, the answer will be simple. We can say Results, View Value, Nodal Results. We can pick this global Y, and you can say Annotate, and this is the deflection under point B. That is 3.566 is the deflection at point B. Of course, at the end of the cantilever, it is minus 9.394. And this is minus 3.566. So in this way, we can solve this problem. And in the next lessons, we'll see a few more 2D problems.